In today's video, we're going to be taking a look at a project I've been working on to build some sort of device that I can use to test network hardware such as routers and firewalls from a single machine. Historically, when I've been testing devices such as routers and firewalls, you'll have seen that I generally use iPerf between two separate machines. I'll run the iPerf server on one machine, the iPerf client on another machine, put each device on either side of the firewall, and test between them. And that works pretty well, but it's a bit clunky. When all I was testing was Gigabit devices, it was relatively easy. You would just use two laptops, one on each side, and that was kind of fine. But now that I'm dealing with devices that are 10 gig or even beyond, I can't really use laptops for that, so I'm having to use servers, I'm having to set up two different desktop PCs, run DAT cables all over the place, need monitors. It's just getting really, really clunky and really messy. On top of that, while iPerf is great, it's a bit limited in what it tests. All it really tests is the maximum TCP throughput between the server and client. So it's almost like a best case scenario of like a network transfer of a large file across the network. Whereas in the real world, in addition to iPerf, you might also want to test with a more tailored packet stream. For example, you might want to try different packet sizes. And you sometimes see this in the specs of different firewalls, referred to as internet mix testing, or IMIX. And this is where you'll be testing with a stream of a bunch of differently sized packets to more accurately simulate what the firewall will be handling in real life. Because generally speaking, a firewall isn't just handling huge packets and huge streams like it will with iPerf. It's going to be handling a lot of smaller packets as well for things like DNS lookups and VoIP traffic, and that will generally much reduce the overall throughput because it's working with much smaller packets, but still having to process a large number of small packets rather than a smaller number of large packets. So I wanted to build a solution that could also allow me to create different packet streams to do more detailed testing. And to do that, I'll be using some open source software from Cisco called TRex, which is really interesting open source packet generation software. So now in this video, I'm not going to be doing a full tutorial for how to use TRex, how to install it, how to set it up in full detail, because it's quite complicated to set up. The documentation is pretty long-winded, and there's been a lot of banging my head against the table to get it to work. But I've got a setup here working, so what we'll do is we'll take a look at it, take a look at it working, I'll talk about it, and we'll try it out. And then, in addition to using TRex, I still want to be able to use iPerf for testing, because it's a really useful tool. But it's a complete pain having two separate machines to try and pass the traffic between. So what I'll be demonstrating in this video is a really interesting thing I've discovered using Linux's network namespaces feature that I had never heard of before I was setting this up. But what that allows you to do is run both the iPerf server and client on the same physical machine and test between them, which ordinarily wouldn't work because the traffic would pass through the loopback interface and wouldn't actually exit the physical machine. But with network namespaces, I've been able to set this up so I can run the iPerf server and client on the same machine and test with it. So we'll take a look at that as well. So now let's go in and take a look at my setup. So first of all, let's take a look at the hardware we'll be using. And if it looks familiar, you'll have seen this before in one of my previous videos, because I'll be using this little 1U server from GoWin. This was an interesting little device in that they sent it over for me to review, and they released it as like a pre-order thing and sent out the pre-orders. But after my review and after some more sort of press feedback, they never actually released this as a fully finished retail product, and instead kind of refined it, polished it a bit, and then released that refined version as a retail product. So you can't really buy this anymore, but it's a really interesting device, and the hardware in it is ideal for what we'll be doing here. Because what we have here is an Intel N305 CPU, which is a really power efficient 8-core chip, 3 2.5 gig Intel NICs, and a pair of 25 gig NICs based around a Mellanox Connect X4. And it's these Mellanox ports that make this an ideal device. Because TRex is somewhat fussy about what network adapters it works with, because TRex relies on what's called DPDK, which is a library that software can use to massively accelerate packet creation and network operations. Because what DPDK does is allows the software to work with a network adapter directly. So rather than all the packet generation having to go through the Linux network stack and all that kind of stuff, TRex can communicate directly with the network adapter and handle packet generation at much higher speeds without bogging down the CPU. But of course that means that the network adapter needs to support DPDK, which not all of them do. So on this, the 2.5 gig NICs don't actually support DPDK, so I can use these for iPerf but not TRex, but these ports will work perfectly fine with DPDK and TRex, which is why this is a perfect device. So if you're interested in seeing any more about this hardware, I've got my dedicated video on that, and I'll put a card up if I remember, so check that out if you want to see the full video on this. But yeah, I've got it all set up, so I've labelled all the ports. We've got the LAN port here, these ports labelled 2 and 3 for iPerf, and these are ports labelled 0 and 1, which is the numbering that shows up in TRex. We'll take a look at this later, and I've made some little helper scripts to make iPerf a bit easier to work with. Other than that, the hardware here is basically stock. The only other change I've done is if we look around the back, you'll see that where it says VGA, there's actually an HDMI port there. That's because this device is a bit interesting in that internally it has an HDMI connector on the main motherboard. But to kind of make it more useful in data centers, they put in this HDMI to VGA adapter that sat in there to give a VGA port, because obviously in data centers and server rooms and stuff, generally you're going to use VGA. But for my setup here, I'm more likely going to be using HDMI. I'm going to be using my sort of HDMI lap dock, which I made videos of previously, essentially a monitor, keyboard and touchpad in a laptop form factor. This is HDMI, so I just swapped that out for a HDMI coupler just to allow me to plug HDMI directly into it. So that's what we have there. So what we now need to do is set this up and test it out. So what I'll do is I'll go and get this packet generator all set up. I'll grab a firewall, get that set up so we can test it. I'll take a look at it working. Okay, so here we have my test setup. So as you can see, we've got the traffic generator set up here, connected to a monitor, keyboard and mouse, and then below it, we have the firewall we'll be testing. And again, if this looks familiar, this is my main firewall. I've actually swapped a temporary one in place of this so I can test this one on the video. And this is a little machine based around an Intel Atom C3558R CPU, and it's running OpenSense. And I'm just kind of interested to try this out and see what sort of real performance this can get. Because when I got it, I first did some iPerf tests, but nothing really beyond that, so I wanted to really put this thing through its paces. So let's fire this up and talk about the software setup. So turn that on there, and we'll wait for it to boot. And as you can see when it boots up, you'll see we're running Rocky Linux 8.9. And this is something quite important with TRex, is that it's very fussy about the particular version of the operating system you're running. If you look at the documentation, generally it talks about CentOS and Red Hat, because it's generally designed for CentOS and Red Hat based distros. Now of course CentOS is kind of not no more, but it's now a rolling release, so it's not really ideal, and Red Hat you're not going to be running as an average consumer. So really you're going to be looking at things like Rocky Linux or Oracle Linux. But this is where the particular version of the operating system you're using is very important. Because when you're using TRex with a Mellanox card, you also need to install the Mellanox InfiniBand drivers, which are available from NVIDIA, who own Mellanox. And those drivers are very closely tied to the particular OS version. So when you install that driver, if you download the driver for Red Hat Linux 7.9, you have to use Red Hat Linux 7.9. It will not work on a newer version. It will just flat out refuse to install. And then on top of that, if you want to use the TRex GUI, which we will be using, it's just much nicer to use, you have to run a slightly older version of TRex, because the most recent versions of TRex have changed some sort of internal API, which means the GUI doesn't work, and the GUI hasn't updated to reflect the new changes to TRex. So you need to run a slightly older version of TRex, which requires an older operating system. And this got really tricky for me, because the version of TRex I'm using that supports the GUI recommends CentOS 7.6. However, the hardware in this machine here is too new for that. And if I install CentOS 7.6, it just doesn't boot. I think it's something to do with the graphics adapter in this. This CPU is newer than CentOS 7.6, so it just doesn't run. And even CentOS 7.9, the later versions of CentOS 7 or Rocky Linux 7 or whatever I was using, they will boot on this machine, but they don't support the 2.5 gig NICs. So the best compromise I was able to find was Rocky Linux 8.9, which is still old enough that the older version of TRex still works perfectly fine, but new enough that it supports this hardware. And I was able to get the Mellanox InfiniBand drivers for Rocky Linux 8.9, get those installed, and it all works. So, as I mentioned earlier, this isn't a full tutorial, but it's just something important to bear in mind if you are setting this up. It's very fussy about operating system versions. Don't just install your favourite Linux distro, the newest version of it, and just go with it. You do kind of need to look very carefully about what OS to use, what distro to use, what version to use, and set that up. And on top of that, you're kind of going to want to set this up as a dedicated machine. Don't go installing this on kind of your favourite server and expecting it all to work, because it's so tied to the operating system version. You kind of want to be able to set up a machine like this, get it all working, and then just never touch it. Don't update it, just have it as a working sort of appliance, which is what I have here. I'll never update this machine unless obviously new version of TRex come out that's supporting your operating systems. This machine's kind of frozen in state as a particular appliance, so just something to bear in mind there. But yep, it's now booted up. So what we'll do is we'll log in, get a screen capture going, and take a look at it working. So there we go, we're now logged in. And then there's one more thing to do before we go and take a look at the software. We need to connect everything up. So obviously we've got the traffic generator here, the firewall below, so we need to connect the two together. So I'm just going to use these DAT cables. And then what I've done for my particular test setup here is I've configured this firewall so that these two SFP Plus ports here are on different subnets, and routing is configured between them, and the firewall allows traffic to pass between these two ports. So what I can do is I can connect these ports into the 2 ports on this, perform a test between these 2 ports, and it will pass through here and be allowed through the firewall. And then within OpenSense, the firewall is currently enabled, but what I can also do is disable the firewall and test the pure routing performance, and we can see how that affects it. Should be quite interesting to try out. So yep, we're just going to plug it all in. So port 0 there, it's going to plug into there, and then port 1 here plugs in to there. So get them plugged in, link light's coming on. So now let's go in and take a look at TRex. Okay, so now we're logged into the machine and we have TRex installed and working. Now, I'm not going to go into the full installation process of TRex, it's way overcomplicated for that, but we'll take a look at roughly at the installation directory. So when it comes to installing TRex, essentially, if you're using a Mellanox card, you need to install the Mellanox drivers, and then TRex itself is just a big tarball that you'd extract. So I've installed it into opt TRex and then v, whatever the version is. That's the version I'm using. And then if you look in there, we see a bunch of different files. So here we have some TRex binaries, and there's a few different folders here. ASTF, CAP2, and STL. And these are for different modes of using TRex. There's stateless mode, stateful mode, and advanced stateful mode. The main difference between stateful and stateless is stateless mode just generates packets and chucks them out the device, whereas stateful mode will run almost a server and a client, and it kind of actually makes a network connection and they properly communicate. So that can be more useful if you're going through some sort of very advanced firewall that's going to perform deep packet inspection or things like that. Or if you want to, for example, have TRex communicate with a web server directly, you would use stateful mode. For this video though, we're going to be just using stateless mode, where we can just generate a stream of UDP traffic, blast it out the device, and watch it pass through the firewall, because that's much simpler. Now if you look inside these directories, so look inside the stateless directory, you'll see a bunch of Python files, a bunch of YAML files, and a bunch of PCAP files. And this is one way of using TRex, is to do it all on command line. You use PCAP files to format the packets you want to send, and then you can write Python scripts or create YAML files that TRex then uses to generate the streams and run the tests. And this is something I want to look into more and learn a bit more about and try out, but it's quite a complicated process, it's not particularly user-friendly, and especially for things like just quickly testing it, it's not ideal. Because this isn't something that I use every day, it's the sort of thing that I'll probably take off a shelf and use once every couple of months or so. So with a very complicated command line setup like this, I just know that even if I learn it, I'll forget it next month when I try and use it again. So instead, we'll be using the GUI, which makes it much easier to use. So the GUI is called TRex Stateless GUI. It's a very descriptive name, and I've just extracted that to opt TRex Stateless GUI. And as you can see in there, it's just a big Java application, it's just a jar file. So let's fire up the GUI and take a look at it working. Now, the GUI itself is just a front-end TRex, and TRex itself needs to run a daemon in the background that the GUI communicates with. That's because you could run TRex itself on one machine, run a GUI on a separate workstation, and have that GUI connect to the TRex machine. Now for me, I'm all running it on the same device, so what we need to do is first of all start this TRex daemon server process, and then afterwards start TRex Stateless GUI. So for that, I've just created a simple shell script that's on my desktop just to make it easy to start. So I've got a single icon that'll start TRex, but what that does is start the daemon server and then start the TRex Stateless GUI Java application. So let's fire this up and take a look at it working. So if we open that up, you'll see first of all it asks for my password. That's because the daemon server has to run as root because TRex interfaces with the hardware in a very particular way. So we'll just put the password in now and start everything up. So let's run that. As you can see, it's firing up the TRex daemon, and in a second, up comes the GUI. And this is TRex Stateless GUI. So the next thing we need to do is start TRex itself. So if we go into TRex daemon, open TRex daemon, connect, we're going to connect the TRex daemon, load the configuration, and this is all the configuration to start the TRex service in the background. Now, I'm rushing through all this. I'm not expecting people to use this video as a tutorial, so I'm just want to get it working so we can take a look at actually using TRex. Not go into too much detail on how to exactly use this, but if you're trying to use this, these bits might be useful. So this is the TRex configuration, which is also located as a configuration file on disk. And as you can see here, we're specifying the two network interfaces. This is like the MAC addresses of the network interfaces that we're wanting to use in TRex. These are the two Mellanox cards. We then have some IP addresses configured. This is for the two ports. So I have two different subnets set up, 10.0.0.1/24 and 10.0.1.1/24. And we have one of these subnets assigned to each of the two ports. And then on the firewall, each interface we're testing has one of each subnet, and then we route between them. And then the firewall that I'm testing has a gateway IP on each subnet of 10.0.1.254 and 10.0.0.254. So that's the IP address of the OpenSense firewall we're testing. Now I know this is kind of a bit backwards having the firewall in 254, not .1, but I set this up by banging my head against a wall and just hitting it until it worked. So the configuration isn't the neatest thing. I've got a bit tidying up to do. So essentially this is how I have it all set up. Port 0 on the traffic generator has an IP of 10.0.1.1. Port 1 on the traffic generator has an IP of 10.0.0.1. And the default gateway has the 10.0.0.254 and 10.0.1.254. And that's the IP of the OpenSense box. Apart from that, there's not really any other advanced configuration in here. I'll just quickly scroll in there so you can see my configuration file in detail. But with all that in there, we can now start TRex. So we press start, and that's going to run the TRex service in the background of the machine, so we can now start using it. Just wait a few seconds for TRex to start. There we go, TRex was started successfully. We can now close this. We can now connect the TRex instance because TRex is now running in the background. Connect the localhost, press connect, and now we're in. And this is like the main TRex GUI sort of home interface. And as you can see over here, we have two different ports. These are our two ports on the front of the machine. And if you saw the hardware before, they were labeled port 0 and port 1, which matches up with what we have here. And if we click onto each of these, we'll see both of these have a speed of 10 gigabits, so they're both linked at 10 gig. This is the current link speed, so if you find that they're not linking at the right speed, this is where you'd want to check that you've definitely got the correct speed. So these ports are all just sitting here, ready to use, but there's one more step we need to do, and we need to acquire them. So to do that, we just click the port there and click this acquire button up here, and it puts, I think it says TRex next to it in the left-hand side. And what this is doing is grabbing that port and using it for TRex. It's telling TRex that you can use that port and TRex will take control over that network interface. So now while we're on the screen, before we actually try and do some testing, there's one more option here that's very important that I mention. And it's this one labeled service. And you'll notice on both ports, they have an option for service mode that you can enable. By default, when service mode is disabled, what TRex will do is just throw away any traffic it receives. If a port receives traffic, it just gets completely discarded and ignored. And that's generally best from a performance perspective, because you're not needing to spend any CPU cycles processing incoming traffic. However, what that also means is that if any incoming ARP requests come in to resolve any IP addresses in the traffic that you're generating, they will also be ignored. Now with this OpenSense firewall, that doesn't make a difference. If you have service mode disabled, it works perfectly fine. However, I've also tested this using a unified dream machine. Now with the unified dream machine, what happened is when service mode was disabled, when you start the stream and start sending the traffic, you'll notice the traffic will run at full speed for a few seconds and then drop off a cliff and go back down to 0. Then when doing a traffic capture, what you see is you see all your traffic flowing for a few seconds, then an absolute ton of ARP requests coming from the dream machine, and then the traffic drops off a cliff and the dream machine stops forwarding it. That seems to be some sort of security measure, either of the dream machine or some part of its network stack, that if it can't resolve ARP for an IP address, it won't pass that traffic. So if you're handling a firewall like that, all you need to do is enable service mode on the ports, and what that then means is if the firewall generates any ARP requests, they will be responded to. Service mode also means that you can use this capture functionality. So in here, there's an option to capture traffic. You can run a traffic capture, and it'll essentially just capture traffic from your network ports. Obviously, I'm not generating anything right now, so you're not going to see anything in here, but this will allow you to capture traffic and inspect the traffic that you're passing through the firewalls. Again, if you want to use this, you have to have service mode enabled. And it's a similar idea to like Wireshark. You can view all the packets and inspect them and stuff, so that's really useful. But yeah, if you want to actually do anything with the package that you're receiving, either to capture them and inspect them, or to respond to things like ARP requests, you need to enable service mode on both ports. And if you don't need that, you can disable service mode and get slightly better performance. So yeah, just important to bear that in mind because that confused me for a very long time. And now we're ready to test. So what do we test with? Well, this is where the concept of profiles come in. A profile is a list of different streams of network traffic that you want to send. And a stream is essentially a single type of packet that you've designed that you want to send out of the network interface at a particular rate. So if we open up an example stream here, just open up this one, we can see we have a bunch of different streams I've created. So this is the profile, here's all the streams. I have a stream of 1518 byte packets, a stream of 590 byte packets, and a stream of 64 byte packets. If you open up one of these, we can see what's inside. We can see that it is a UDP packet, it has a fixed size of 1518, We can go into profile data, we can see the IP address. It comes from, goes to a destination of 10.0.0.1 and a source IP of 10.0.1.1. You'll remember that that's the IP address we have configured for the network interfaces and also the IP addresses that are configured on the firewall. It has some UDP headers you could override if you wanted, and some payload data which is just random, so it just fills the packet with random data. But as you can see in here, you could really customize this. You could customize the exact stuff about the UDP, customize the ports, you could change IP addresses. We'll take a look in a minute. You can set a random host, so you're not just sending a particular IP address, you're sending it from a bunch of different IP addresses or to a bunch of different IP addresses. Loads of stuff here. And if you look at the packet viewer on the end, here we can see a sort of example of the packet this would generate. So we have an Ethernet header, the IPv4 header with different IP addresses in it, UDP header with all the UDP stuff, and then the data is just a bunch of random data. But with that stream set up there, we can now use TRex to send this packet out of the network interface at a particular rate. So here we'll just test with this here. So we have that test set up there with a 1518 byte packet. Now let's send it. So first of all, we can see up here, we can configure the rate that we're going to send this at. And you can define this in a bunch of different ways. You can define it in numbers of packets per second, the layer 2 bit rate, or the layer 1 bit rate. So I'll just do the layer 1 bit rate. That's generally the easiest one to imagine. And that's currently set at 100 megabit. So now we can start this working. So if we press play here, that'll start that stream running. And what you can't see, but the port activity LEDs on the firewall are now blinking. As you can see here, it's showing the port is, well, the port's flashing green. So what we can now do is view the stats. So there's this little button here to pull up a dashboard, and if we pull this up, you can see we are sending at about 100 megabit, and we're also receiving at 100 megabit. So that's showing that the 100 megabit of traffic is passing completely through the firewall. There's a 0 bits a second drop rate, so we're not dropping any packets. The firewall is perfectly well handling a 100 megabit stream. So now we can stop that, we can come back here, and we can change this. So we can, for example, put this up to, say, 500 megabit. So 500M, put that in there, press play again, come back over, and as you can see, we're now passing 500 megabits through the firewall. And yep, it's handling that completely fine without dropping any packets. But now let's try speeding this up even more. So we can turn it up, say, 10 gig and press update. So now if you look at this, you'll see we've got something a bit different. You can see we're generating around 9.5 gigabits a second of traffic, but we're only receiving about 1.5 gig, 1.6 gig back. And that's because we're now maxing out this firewall. And this doesn't look very good. 1.6 gigabit through a firewall with 10 gig interfaces, that's not great, is it? But that's because if you look back at the stream here, you'll see my name for this is single source. And if you look inside the stream here and look at the protocol data, you can see the data comes from a single source IP address. Now this sort of behavior varies between different firewalls, so I'm not going to go into too much detail right now. But generally with a firewall, if they see traffic that's going from the same port to the same port, from the same destination to the same destination, they group it into a single stream and process that on a single core. So while this firewall is quad core, this stream is only being processed on a single core. You'll see the exact same behavior with iPerf. If you run a single iPerf test, you won't get the full performance. Whereas if you run multiple parallel iPerf tests using the -p flag, you'll get better performance. So for that, I have a different stream that instead of using a single source, it uses a random host for the source. So instead of sending all the traffic from a single source IP address, it picks a random source IP address between 10.0.1.1 and 10.0.1.128. So what we'll do is we'll load up that stream here instead. So this now is configured to send from a bunch of random source IP addresses. Start this up, set to 10 gig, press run, that's flow will start running, and now we can see we're passing about 5.5 gig, about 6 gigabit a second. Now it's not hitting a full 10 gig, this firewall doesn't hit a full 10 gig, but we're now getting a much better throughput because it's now using all of its cores together. So there you go, that's it working. We're now sending a stream of 1500 byte packets through the firewall at 10 gig, we're receiving 6.5 gig back, so the firewall's kind of capable of 6.5 gig of 1500 byte packets. It's that simple. There's a bunch of other stuff you can look at here as well. For example, there's different charts. You can see there's a chart of the throughput. So this is the throughput in packets per second. You can also view the throughput in packets per second. You can go, right, I want to see the received bits per second instead. So that's the received bits per second at about 6.5 gig. So you can get graphs. It's pretty useful. So of course that's testing with 1500 byte packets, which is generally similar to what iPerf is going to do. But what we'll now look at is the beauty of using something like TRex, and that is for internet mix testing. Internet mix, or iMix, what you see here, is something you sometimes see advertised alongside different firewalls. I know Netgate advertise all of their firewalls with two different speeds, an iPerf speed and an internet mix speed. And the idea with internet mix testing is that traffic going through a general firewall out to the internet is never all 1500 byte packets. There's a big mix in there. You have a decent number of large packets, but you also have a lot of very small packets for things like DNS lookups and VoIP traffic. So there's a lot of different formulas you can use, but one of the kind of common distributions of internet mix traffic, known as simple iMix, is where you have 64 byte packets, 590 byte packets, and 1500 byte packets. And the idea is that in your stream when you're testing, you want a different distribution of these packets. So based on the example I have here, what we want is the stream to be made up of 58% of the stream to be made up of 64 byte packets, 33% of the stream to be made up of 590 byte packets, and 8% of the stream to be made up of 1500 byte packets. And the idea of this is kind of what is believed to be seen as a sort of standard sort of internet traffic a firewall is going to receive. Of course, your application may vary, and you will likely want to tailor this to your particular application. For example, if you've got a firewall that's handling mostly VoIP traffic, you might want to test a lot more with smaller packets, whereas if you've got a firewall that's handling big transfers generally, you might want to test with just larger packets. But then to get those kind of percentages of the distribution, we adjust the amount of packets per second that we send for each stream. So the 64 byte stream sends at 7 packets per second, the 590 byte stream sends at 4 packets per second, and the 1500 byte stream sends at 1 packet per second. And that kind of gets the right distribution to match sort of simple iMix standard. Now of course this is a very slow packet rate, but the idea is that this is the sort of proportional amount rates that we're sending each of these packets at. What we then do is we adjust the actual total amount of bits per second we want to send as part of the stream, and it sort of multiplies these up to scale it up to the right level. So right now, for example, if we say what we want to do, I don't know, a 5 gigabit stream, that's a 5 gigabit stream, and that will be made up of mostly 64 byte packets, followed by 590 byte packets, followed by 1500 byte packets, using these rates here. So what we'll now do is we start up this stream at 5 gigabit a second, and take a look at the performance. And what you'll see here, if you look at the dashboard, you'll see we're now getting much lower throughput. Whereas previously we were getting about 6.5 gigabit of throughput, we're now getting about 1.3 gigabit of internet mix throughput. And this is why it's quite important to test internet mix throughput of a firewall. Because if you're buying a firewall that rates itself as capable of 10 gigabit throughput, yeah, it probably can if you're doing iPerf, but if you're actually wanting to put real world internet traffic through it, you're going to get a lot lower due to those small packets. So it's really interesting to be able to test it like this. Okay, so that was a look at the firewall performance. What I've now done is I've gone into OpenSense and disabled the firewall. So I've disabled the packet filtering side of OpenSense. So now it's purely working as a router. So what we can now do is see the performance of this box as a router, not a firewall. And that should be a fair bit faster. So once again, we'll test with a 1500 byte stream. Let's start that up and see what we get. So as you can see now, we are easily hitting 10 gig throughput. We are matching the input speed to the output speed pretty easily. Even turn the bandwidth up here a little bit, send it up to full max 10 gig, update that. And as you can see, we're sending 10 gig and we're receiving 10 gig. So with the firewall disabled, this device is perfectly capable of routing at 10 gig. So what about internet mix? So if we come back here, what we can now do is enable smaller packet streams. Update the stream now and see what we get. So what we can now see is that we're sending in 10 gig. We're now receiving about 3 gig. So now if we're talking, what I'll do is I'll drop the bandwidth down a little bit just so we're putting less data into the firewall just so we're not overwhelming it. But yeah, what you can see here is when it comes to internet mix throughput, with the firewall enabled, we're getting about 1.3 gigabit a second. With the firewall disabled, we can route about 3 gigabit a second, which is a fair bit higher. So yeah, that's kind of look at testing the firewall with TRex. How we can send both a 1500 byte stream to simulate large file transfers, or how we can send a bunch of smaller packets in multiple different streams and use that to simulate internet mix. And while this software is a little bit janky, it's one of those applications that takes a lot of fiddling to set up and the documentation isn't that great, and then the GUI is a little bit buggy in places. Now that I have it set up and working, this is going to be super useful for testing out firewalls. It's definitely extremely powerful software. And of course right now I'm testing with a 10 gigabit capable firewall, but what I have done previously is I've done a loopback test where I've just plugged 2 ports on the packet generator into each other and used TRex to send packets through them. this can easily send packets at well over 20 gigabits a second, almost hitting 25 gig. So that means that this traffic generator will be useful for testing any firewalls in the future, all the way up to 25 gig capable firewalls. It's going to be a really useful tool to have. So there you go, that was a look at TRex. Now it's time for the other thing I promised, which is where we take a look at how I'm running both the iPerf server and the iPerf client on the same machine to test between the two network ports. So let's go and do that. So what we'll do is we'll close down TRex, and I'm going to actually reboot the machine. I do this with both when I'm switching between TRex and then you're doing iPerf testing, or switching after doing iPerf testing to do TRex testing. I like to reboot the machine, just because both TRex and the iPerf setup kind of lock network ports and set various network configuration. It's just much safer to cleanly reboot it, and that way there's no issues with any kind of leftover config causing issues. So we'll reboot this, and then we'll come back. Okay, so now we're rebooted, so let's take a look at iPerf. So what I want to do is run both the iPerf server and the iPerf client on the same machine. And if you've ever done this before, you'll know what's going to happen now, because we'll take a look at it. So what we have is, as before, the firewall is plugged into the go-in box with two DAC cables. The firewall also has DHCP set up, so if I come into here, I can press also Ethernet on each of these network adapters on the Melnox, and both of them will get an IP address over DHCP. If you open up a terminal here and run IP adder, you'll see, there we go, both of the Melnox interfaces have an IP address, as you can see there and there. So we're now set up. So let's try and run iPerf on this, with both the server and client on the same machine. So we have one terminal there for the server, one terminal there for the client. Run iPerf 3-S for the server, run iPerf 3-C for the client. What we want to do is we want to use the client IP address to be this one here, so 10.0.1.1, 10.0.1.1. There we go. And let's run the test. And you'll see the problem. That's saying we're getting a bit rate of 50 gigabit. Now, how are we getting a bit rate of 50 gigabit over a 10 gigabit connection? That's because the traffic is never leaving this machine. Because as you can see on this machine, the machine has both IP addresses. So if I tell iPerf to test to one of the IP addresses, the traffic is forwarded directly by Linux. It never leaves the machine. And this is the issue with running the iPerf server and client on the same machine. But there is a solution, and it's called network namespaces, which is a really interesting feature of Linux that I have never seen before, and it is super useful. So what network namespaces do is allow you to create multiple different sets of network interfaces and routing tables that are completely isolated from one another. You can then run different applications inside a namespace where that application will only have access to that particular set of network interfaces. And if we do that with iPerf, it means we can run the server and client in separate namespaces, and that way they can never communicate directly. So let's set this up. So what we do is, I've got a root shell here. You do need to run all these commands as root. So what we'll do, first of all, is we'll create two different namespaces. One for the iPerf client, one for the iPerf server. So to do this, we're going to run IP netns add client and add server. So that's our two network namespaces created. So now we've created the namespaces, what we now need to do is assign our network interfaces to them. We'll assign one port to the client namespace and one port to the server namespace. So what we'll do is we'll go IP link, just get a list of network interfaces. So let's assign them. So what we're going to do is go IP link set dev and then pick a device. So we're going to pick this one here, which is the first 25 gig NIC. Put that in there. netns server. There we go. What we're now going to do is do the same, but for the other network interface, so F1 NP1, and assign that to the client namespace. And now that we've done that, what you'll now notice is if we run IP link, those two network interfaces have disappeared from the host. That's because they're now assigned to those network namespaces and are now isolated. So how do you use these namespaces? Well, once they're created, you can then use the exec command to run particular applications inside a namespace. So for example, as you can see, if I ran IP link here on the regular host, we don't see these new interfaces. But if we run IP netns exec server IP link, what we're saying here is execute the IP link command inside the server namespace. And as you can see there, we have one of our network interfaces. On the other hand, if we do the same, we exec inside the client namespace, we now see here, we have the client network interface. They are now inside those interfaces, inside those namespaces. And with that, we're almost there. All we need to do now is bring up those network interfaces, give them an IP address, and we can start running iPerf. So to bring them up, we're then just going to run IP netns exec server IP link set dev, pick whatever interface is inside the server container or server namespace, which would be this one here. So that there, up, run that there. And that's now brought that network interface up. So do the same for the one inside the client namespace. There we go, that's them now up. Finally, we just need to give them IP addresses. So of course you could set up a static IP, but on my firewall I'm running a DHCP server, so we can just use DHCP to get some IP addresses. So IP netns exec server dh client -i enp5s0 f0np0, and then I'm going to do no PID, just because I want to run two separate instances, -1 to get a single IP, and then we'll quit. So run that. And that's now got an IP address. We'll do that again for the other one. I'll also do -v so we can see more debug information. So we'll now run that on the client namespace. And there we go, that's us getting a DHCP IP address. So now, if we look inside each of these namespaces, we'll see some IP addresses. So IP netns exec server IP adder. We can see inside the server namespace, the interface has this IP address, and then inside the client namespace, we have this IP address. That's now set up. So now we can run iPerf. Okay, so now we're ready to test this out. So what we have here is two different root shells. On the left, we'll run the iPerf server, and on the right, we'll run the iPerf client. So we want to execute these inside the namespaces. So we're going to go IP netns exec server iperf3-s. And there we go. We're now running the iPerf3 server inside the server network namespace. So now we need to run the client. So the first thing we want to do is once again double check, because I've forgotten what it is, get the IP address of the server. So to do that, we're going to go IP netns exec server IP adder. And that's given us the IP address of the server network namespace interface. So now we can run the iPerf client. So IP netns exec client iperf3-c, so it's the iPerf client running inside the client network namespace. I'm going to put the IP address of the server, so 10.0.1.1. So this is essentially the same two commands we ran previously, but now they're inside a network isolated into different network namespaces, so they can't communicate directly. So now if we run this, we should get a successful iPerf test. And there we go, iPerf is now running. And as you can see, we're now passing about 3.3 gigabit between the two tests. That's working. And as you can see, it's no longer 50 odd gigabit, it's now 3.5 gig, which is the throughput of the firewall. It's now working. Now, of course, that does look a little bit low, especially given the firewall isn't currently running on the OpenSense box. But as before with TRex, this is because this is a single stream and it's all being processed by a single thread. So now if you run -p4, this will run 4 parallel streams. And what we'll now see is we'll get much better throughput. We're now getting, what's about 7 gigabit. Try running potentially even more streams than that because they might not be being assigned perfectly across all the cores evenly. So say, let's do 8 different streams. And there we can now see we are routing at basically 10 gigabit. So yeah, that's now working. We're now testing this firewall with iPerf, all from a single device. So that's a demonstration of how to use iPerf with network namespaces. As you can see, they're very easy to do, but it's quite clunky to set up every time you use the machine because you've got to create the namespaces, assign all the network interfaces, all that kind of stuff. So just to very quickly showcase what is very easily possible, what I've done on my test setup here is I've created a bunch of helper scripts. So the first script I have is one called setup ports, and if I run this, what it'll do is it'll create the namespaces, it will assign all the ports to the namespaces, and it'll run DHClient to get an IP address across all the ports. So we'll run this, it needs to run as root, so I'll put my password in, and we'll watch it run. Okay, so the password's in, press enter, and what you'll now see is it's running a bunch of DHCP requests. And it'll do this 4 times, because what this is doing is it's creating a namespace for all 4 network ports on this device, both the 2 10 gig ports and 2 of the 2.5 gig ports. So with the setup, I can also use it to test 2.5 gig devices with iPerf. So that's really useful. So that's all run there. It's got DHCP IP addresses on the 2 interfaces that are connected. The ones that aren't connected just won't get an IP address and will just time out. So now we can use it. So the other script you'll notice here is I have ones called on port 0, on port 1, on port 2 and on port 3. And these are extremely useful for just making this much more friendly and easy to use. If we take a look at one of these scripts, say on port 1 or on port 0, as you can see, all it actually does is execute IP netns exec port 0 sudo user TRex, so it just runs it as a TRex user rather than running it as root, and then executes whatever command was passed in. So it's almost just an alias for this much more complicated command. But what this means is if I want to run something on port 0, I can just do it. So if I want to say get the IP address of port 0, all I need to do is run /on port 0 IP adder. And that's the IP address of port 0. Likewise, the IP address of port 1, run on port 1, we get the same thing. So this makes it much more intuitive and just kind of self-explanatory and easy to use. So to do an iPerf test, all I need to do is run a setup port script. Once that's done, then on port 0, run iperf-s, like that. That's now running the iPerf server on port 0. Now over here, on port 1, we want to run the iPerf client. And then we want to use the IP address of port 0, which is 10.0.1.1. And then we'll do it across, again, 8, let's put it in here, do it across 8 threads. Please put the password in again, and let's run the test. And there we go, that's it working. So that goes to show that even though it's a little bit fiddly and complicated to set up with just a bunch of commands and trying to get it all working, you can very easily create some helper scripts like that and get a very easy to use end result. So there you go, that's a look at my new traffic generator setup and how I can use this single device here to test firewalls all the way up to 25 gigabit, and how I can use both iPerf and TRex to generate more bespoke traffic streams. And it works really well. In fact, after sort of finishing the screen recording, I've actually set it up now with 2 separate streams, so I'm now sending 2 10 gigabit streams in each direction through this firewall. We're now generating about 20 gigabits of traffic, and the firewall's passing about 14 gigabits of that. So yeah, it works really, really well. Now, this video was probably very long-winded and very technical and probably not explained that well, so very well done if you have stuck to the end. I imagine most people probably gave up after the first 10 seconds, but hopefully you found this interesting. It's definitely quite fiddly software to get working and the documentation is very technical, but once you get it working, this software is so useful and I can't wait to try this out in the future to test more firewalls. So yeah, hopefully you found this interesting. And hey, it may have even inspired you to go out and try out TRex. I mean, probably not, it's a very niche thing that most people definitely don't need. But yeah, hopefully you found this interesting. But all that's left to say now is thank you very much for watching.